All right. All right, let's begin. What we've been doing up to this point is we have been reviewing some math skills needed to take and to do basic physics. We shall continue to do that. Yes, the last time we met, and you should look at it, we plugged into some equations. That's very important. What's the one thing you need, Victoria, in order to do that? You need a calculator, which is very important. How many people feel that a calculator is going to be important in this class? Raise your hand. How many people will not bring a calculator next class? You just thought you'd be different. Okay, very good. Excellent, I like that, divergent thinking. As long as you're lying, that's good. Okay then, so you've got to bring a calculator. It's going to be a homework assignment. Parents, homework assignment to bring a calculator. Understood? I don't care if you lost it. Some giant prehistoric dinosaur broke into your house, ripped off an entire wall of your house, went in, specifically found your calculator and ate it, and then left. And you're like, what is going on? I don't have a calculator for Darcy's class. Well, you know what the answer is? Figure it out and get a calculator in class. Clear? And please don't borrow a calculator that is the most confusing, confounded, unbelievably complex, such as a TI-89 to do basic math with squares and square roots and tangent and sine and cosine, which we'll do later on. Hopefully we'll get to that. Very basic scientific calculator. You do not need a graphing calculator. If you have one, guard it, because they are an item that is oftentimes stolen. Clear? So let's talk about linear motion, and we're going to do the basic understanding of linear motion. Okay? There's two things we want to talk about. We want to talk about average velocity. We want to talk about instantaneous velocity. And we want to talk about acceleration. The kinds of acceleration we want to talk about are uniform and non-uniform. Okay? We're going to keep this very simple. Give me 10 minutes, 15 tops. Then you have time to maybe do some problems. Clear? Okay. So, average velocity, instantaneous velocity, and acceleration. Okay. Here I am in Abu Dhabi. Okay, here I am in Abu Dhabi. And I want to go to Dubai. Okay? Yes? Okay? Now, I do that, and I drive there, and I say, well, how far was it? I'll say it's 50 kilometers. It's probably farther than that. Shall we say 75? No, we'll say 60. Probably something like 60 kilometers. Okay, that's fine. All right, now, it's going to take you, if you obey the speed limits, let's say it takes you 2 hours. It's not going to take you 2 hours, but we're just making up a problem, okay? Yes? So, we have the distance equals 60 kilometers. We have the time equals 2 hours. That's all the data you have, okay? Now, you have to ask yourself a question. When I'm driving in a car to a destination, is my acceleration uniform throughout the entire trip? Or does it change? In other words, Do you accelerate, decelerate, accelerate, decelerate? How are you going? Are you going to accelerate uniformly throughout the entire trip? I'm going to accelerate from Abu Dhabi to Dubai, and then that's it, and I get there. Does that make any sense to you whatsoever?
Yes.
It does?
No.
No, Sky, I'm not asking you to guess, okay? The answer is unimportant, okay? I'm not sure is a better answer than yes as a guess. Understood? Okay. You're in a car. Everybody close their eyes. Close your eyes. I'm telling you, close your eyes. Close your eyes. Okay, here we go. All right. You're going to Abu Dhabi with the family. You're going to see the Burj Dubai. Okay, you're home. All right, where do you live? Picture where you live. Okay. You live, maybe you have a driveway in Al Reef, or you are living in Marina Square, or whatever the case may be, and you're in a parking garage. What are you going to do? You're going to say, back out of the space. You're going to accelerate just a little. You're going to back out of the space. Then you're going to stop. Then you're going to accelerate. Then you're going to come to a corner. You're going to slow down. You're going to take that corner slowly. Then you're going to hit a little bit of a straightaway. You're going to accelerate. Then you're going to come to a stop. Then you're going to make a left at a stop sign. You're going to you're going to be out of the building, and now you're on your way. You're out of the parking garage. Now you're accelerating, and you're going down the road. There's a signal, there's a red light. You've got to stop. Okay, I stopped. Now I've got to get on 10E. All right, I'm on 10E now. Now I'm on 10E and I'm accelerating. All of a sudden you see this red, the road is partially red. So you have to slow down to 80 kilometers per hour. Now you're through that side, you have the cameras, you can't get a ticket. Now I'm past that red, now I'm going to accelerate even more, right? I'm going to accelerate, right? I decelerated when I hit that red spot. Now I'm going to accelerate. Now I'm going, maybe I'm going. 120 kilometers per hour, I'm moving. All of a sudden I get onto 11E, and it's so much traffic. You can only go 60 kilometers per hour. It is so much traffic, so I got to slow down. Now the traffic clears and I speed up. Okay, now open your eyes. Let me ask you a question. Did you uniformly accelerate during that trip? Once. In other words, you accelerated. You went from Abu Dhabi. All right. Here's velocity. Here's time. I started out in my garage, and I'm here. Is that what you did? Did you do that? You did, Nora? You're shaking your head yes. So you accelerated? You did. So you were in your parking garage, and you hit the accelerator once, accelerated uniformly, and got to Dubai. I'm asking you a question. You did? No, you didn't. Didn't you start, stop, start, stop, start, stop, fast, slow, fast, slow, fast, slow? Didn't you do that? So wasn't your acceleration all over the place? Was it, Laura? It absolutely was. You went like this. This is what it looked like. We wouldn't even work with a graph like this. This is what we did. Okay? You get out of your parking space. You come to a stop. You speed up. You hit a corner. You slow down. You speed up on a straightaway. You come to a sign. You've got to stop. Then you accelerate. Then you slow down. Then you accelerate. Is that uniform acceleration? Look at all these accelerations. Right? Is that uniform acceleration? Absolutely not. Okay. All right. How do I find my average velocity if I don't have uniform acceleration? How do I find it? This is it. You ready? This is your first big calculation of the physics. Are you ready? I'm going to show you how easy this is. Didn't it sound complicated? But it's really very easy. Are you ready? Are you ready? Okay. Average velocity. right? Average, okay? Ready? Non-uniform acceleration. Okay? Are you ready? Equals d over 2. That's it. So what was my average velocity going to Dubai? Take out your calculator, if you need one, and tell me. Yes. 30 kilometers per hour. So V average equals d over t equals 60 kilometers over 2 hours. So V average equals 30 kilometers per hour. Not realistic numbers, but okay, fair enough. Okay? Yes, do you see that? Do you understand that? Let's see what we did. Okay? All right. We have to find average velocity. That's what we're trying to find. Okay? All right. Well, you have to decide whether or not you have uniform or non-uniform acceleration. We had non-uniform acceleration, okay? Therefore, we used this equation. Clear? That equation is for non-uniform acceleration. Average velocity equals d over t, non-uniform acceleration. Understood? And you get 30 kilometers per hour, correct? Okay, good. I'm going to erase this, is that okay? I'm almost done. Okay, you ready? Okay, so velocity average d over t non-uniform A. All right, now, before we do a different kind of average velocity, let's talk about this. Instantaneous velocity, excuse me. What's instantaneous velocity? What is that? Yes? No. Here's my speedometer. All right? It's not like that, obviously. But let's say it was, right? Let's say it was pointing at, I'm driving and I look down and it says 30. Right? That's my instantaneous velocity. Instantaneous velocity is speedometer reading. At an instance in time. At an instant in time. Do you get it? Yes or no?
I get it.
Yes? You sure? Okay. Very important. Next time you're in a car with your parents, will you do me a favor? And if I see your parents in school and they come up and tell me, Mr. Darcy, my daughter or son asked me we were driving home and they asked me what the instantaneous velocity was. And I was very surprised. I didn't know what that meant, right? If they come up and tell me something like that you actually asked them, Mom, what's the instantaneous velocity right now? They're going to be like, what? You tell them, well, the instantaneous velocity is the moment in an instant, in this instance. And they're going to say, you're going to say, well, you're going to look over and you're going to say, Mom, you're going 90 kilometers per hour. Slow down. Okay? Speed limit 60. Clear? Understood? Okay, good. Now, what happens if you had uniform acceleration? In other words, I start here. This is velocity, 0. This is time, 0. Okay? How are we doing with the chairs? You okay? Okay? Right now. So you have velocity. All right, now. I'm stopped. I'm on a track. I'm stopped. Here's my track. I'm here. I want to go here. This is going to be 100 meters. Okay? Well, let's make it simple. Let's say it's going to be 1 kilometer. Okay? And I'm right here. Right? No, let's say meters. That's too weird. Okay, here's a meter. 100 meters. Okay? Now, I'm going to press the accelerator, and I'm going to go from here. I'm going to go from here to here. Right? And it's going to take me 10 seconds. All right? It's going to take me 10 seconds. All right? I want to know the instantaneous velocity here, and I want to know the average velocity. Shall we do it? Okay, here we go. You ready? This is a cool problem. Actually, it's going to take me 5 minutes. So what I'm going to do is, I'm just going to solve it, so then at least you can see it over the weekend. Okay? Yes? You sure? Okay. So it was here to here, correct? Yes? Yes? Okay, so 100 meters, right, in 10 seconds, which is 10 meters per second, correct? We don't do kilometers per hour, believe it or not. You work in distance is meters and time is seconds. So we'll do some conversions, but we'll do meters and seconds, okay? So, and that is average velocity, isn't it? Isn't that average velocity? Now, is this uniform acceleration? Yes, this is uniform. That's uniform. So if you have uniform acceleration, you can use this equation. You can use that equation to do uniform acceleration. But let me show you the difference, okay? The equation for uniform acceleration, the specific uniform acceleration equation is v average velocity. Sorry, that's a technical use of that. This is average velocity, uniform A, equals initial velocity plus final velocity divided by 2. Okay? Do you understand that? Yes. Now, we know that that's an average velocity, don't we? Is that an average velocity? Is it? Is that an average velocity? Yeah, because I used d over t, didn't I? I used d over t. This is going to be d over t equals v average, right? So isn't that an average velocity? Remember, I said you can use this equation for, you can use that equation for uniform or non-uniform acceleration. The problem is you cannot use this equation. You can't use this equation. You cannot use it unless you have uniform acceleration. Clear? All right, now, hang in there. Give me 60 seconds, and I'll show you what I mean. Okay? Are you ready? All right. We know that this is going to be 10 meters per second. correct? All right? It's going to be 10, just leave it. It's going to be 10 meters per second, correct? Okay. So I have average velocity equals initial plus final divided by 2. And I said to you, I want to know the instantaneous velocity there. Isn't the instantaneous velocity there VF? Isn't it? Yes? I accelerated. However fast you were going there, isn't that the camera takes the picture, right? Which horse was going faster, which car was going faster, photo finish, you've heard of it, right? Yes? Okay. So, I know what the average velocity was, don't I? What's the average velocity? What's the average velocity? What's the average velocity? I just calculated it. 10 what? 10 meters per second. So you plug in here, 10 meters per second. What's the initial velocity? What's the initial velocity? Aren't you at rest here? Isn't that 0 meters per second? Isn't it? Yes? So that's 0. So it's going to be 0 plus VF over 2. Does anybody know the answer yet? What's the answer? Can you solve for VF? Shall I leave out the unit labels? Is that okay? Is that okay? Doesn't this reduce to 10 equals 0? That's 0, right? VF over 2, doesn't it? Doesn't it? Now cross multiply and divide. What's VF? What's VF? Yes? 20. Now, this is your homework. You've got to do the problems at the end of chapter 2. Okay? And this is what we'll say. You have to do all odd problems. It's a lot of work. You've got to write out the question and then write out the answer. Yes? When you take physics, I want you to have these. If you just have the answer, how do you know what the answer is if you don't know what the question was? So it's going to take a long time, yes? Now, this is what I'll do. Some of the questions are hard. You have to do all odd problems, correct? However, if you'll petition me during class, Joseph will say, Mr. Darcy, problem number 50 is really difficult. I can't do it. Please do it in class, and let's determine whether or not it will count in homework. I'll do problem 50 and I'll say, that problem is too hard. If you do it, extra credit. But guess what? Didn't we do it together? There you go. It's win-win. All odd problems, chapter 2. That's your homework. Is that clear? That's all your homework it is. I'm going to give you some worksheets here and there, but unless I give you worksheets, which I will, because you need practice on specific things, that's your homework. Out of the book, chapter 4, I handed you chapter 4. Odd problems from chapter 4. Write out the question, then the answer. Vivian. I didn't give you chapter 4?
Yes, no. About which one?
Okay.
I'll show you.
We'll talk about that after class. I gave you chapter 4. Okay, so you want to do chapter 4 and then look at the problems. Is that clear? Okay. See you later.